All right, we're going to start on page 9 of the ISN and finish it up today. Isosceles triangles, we did discuss at some points, but we're going to talk a little more in depth about them now. Parts of an isosceles triangle. The angle formed by the legs is called the vertex angle. So angle A is your vertex angle. I'm going to label these parts as we go. The other two angles in an isosceles triangle are called base angles. So angles B and C are base angles. Isosceles triangles have two congruent sides called the legs. This side's the leg and this side's the leg. The third side of the triangle is called the base. So that would be side BC. Okay, in an isosceles triangle, if two sides of a triangle are congruent, then the angles opposite them are congruent. So in this figure, angle B would be congruent to angle C. And that's what that says on that second line. So if AB is congruent to AC, then angle B is congruent to angle C. The short version for that is if you have an isosceles triangle, so I'm going to draw a little triangle that's got two sides marked congruent, then the base angles are congruent, which would be these angles across from there. Find your way. Okay. I just have to stay by the computer to talk to it, otherwise I could walk around. Anybody? Yep, just a sec. So that's just saying if it's an isosceles triangle, then you've got base angles that are congruent. That's all that means. Okay, ready? Converse of the isosceles triangles theorem says, if two angles of a triangle are congruent, then the sides opposite them are congruent. So in this case, if angle B is congruent to angle C, then side AB would be congruent to side AC. Okay, and that's because you have those angles marked congruent. So the short version for that is if two angles congruent, then sides opposite those angles are congruent as well. A corollary to the equilateral is about an equilateral triangle. A triangle is equilateral if and only if it is equiangular. So each angle of an equilateral triangle will measure how much? The three angles of every triangle adds up to 180. So if you take 180 divided by 3, every one of them is going to be 60. The short version of if equiangular then equilateral be if equilateral then equiangular. It's just the same kind of thing as when it was isosceles, except it's all three sides and angles. You can also go in the opposite direction. So if all three angles are congruent, then all three sides would be as well. So you can go forwards and backwards with that one too. All right, so all of these angles, angle A is congruent to angle B, which is congruent to angle C, and they're all equal to 60 degrees. Okay, we're going to flip the page, right? Go to page 10, or are we on 11 now? 10? Okay, page 10. Now we're going to do some examples using those concepts. The vertex angle for this picture would be angle H. It's the angle between the sides that are congruent. The base angles then are angles F and G, and they are congruent. The legs are the sides that are congruent. That'd be FH and GH. And the base is the segment FG. Okay, so you have to look at where your congruent sides are to determine where your congruent angles are and where your vertex angle is. Okay, example 1. Given that BC is congruent to BA, the sides angles opposite them would be congruent. So since BC is congruent equals BA, then a measure of angle A is congruent or equals the measure of angle C. So we can substitute in for the measure of angle A, 5x minus 10. And for angle C, 4x plus 5. And now we'll solve for x. So we'll subtract 4x from both sides. That would give us x minus 10 is equal to 5. And then we'll add 10 to both sides. Finally, we'll have x is 15. Okay, example 2 shows two angles are equal. So since two angles are equal, then we know the sides opposite those angles are equal. So across from angle P, there's a 3x minus 13. Across from angle S, there's a 2x, and those are congruent. So since the measure of angle S is equal to the measure of angle T, we know that SR is congruent to RT, or TR. So we need to set those equal. 3x minus 13 equals 2 times x. I don't want to subtract 2x from both sides because then I'd get 0 over here. So I want to subtract 3x. Yeah, I want to subtract 3x. I bring down minus 13. 2x minus 3x would be negative 1x. And now I would divide both sides by negative 1. And I would get the answer of positive 13. Okay? We all right? All right, now example 3. Find x, the measure of each angle. Well, how big are each of these angles if this is marked that they're all three the same? If all three angles are equal, all right, they're all 60. All right, if the angles are all the same, then the sides are all the same. So that means we can set those two sides, 6x minus 5 equal to 5x. Well, much like the last problem I did, I don't want to subtract 5x because I'll end up with 0. See what I'm saying? If I take away 5x from both sides, I'm going to have x minus 5 equals 0. So I'm going to subtract 6x. Got to get my x's on one side. All right, we get negative 5 equals negative 1x. Divide by negative 1, and you get 5. Okay, in example 4, what kind of triangle is this thing? Isosceles? Okay. Isosceles. And the angle tells us it's right. Correct. All right, so the angle measures, we already determined one is 90. How big are the other two? They are equal. How big are each of them? How much? 45. How do you get that? If one angle in a triangle is 90, the other two add up to 90 because 180 minus 90 is 90. Okay, now they're both equal, so we'd have to divide that by 2, the 90, and that gives you 45 each. So they're 45 degrees apiece. Now that we know they're 45 degrees, well, we could have done something else to figure that out, but I'm going to find x now by saying, well, 2x plus 3 would equal 45. So I'm going to subtract 3. Get 2 times x is 42, and then divide by 2. So hopefully you've already got x is 21. Okay? Bang. We already did the hypotenuse leg theorem. Let's see. I think what you have next, I just got to find the right page. Right there, right? All right, is this your page 11? Okay, last thing to fill in. And then we're going to go to the packet. Using CP/CTC after proving triangles congruent. Notice it says after. That means we're going to prove some triangles are congruent before we use CP/CTC. Okay? CP/CTC stands for corresponding parts of congruent triangles are congruent. So what it means is, once you say some triangles are congruent, you can say the rest of their parts are congruent. So here's the deal. Let's see what we're going to try to do on this picture. It says angle SPT is congruent to angle RQT. Let's go look at that and see what it is on our picture. SPT, that's this angle right here. Congruent angle, where is it? RQT, which is up here. Okay, that's inside of this triangle and this triangle. Now I got to figure out what triangles to make congruent. So I have another statement that's given that says ST is congruent to RT. Okay, so far that stuff's been given. I'm going to look at what I'm trying to prove because I need to try to figure out what triangles to try to prove congruent. So it says I'm trying to prove PT congruent to QT. So that to me says that I'm going to get a highlighter. And that to me says I want this triangle congruent to this one. You see what I'm getting at? Okay, because now I've got, and I'm just going to color that in because I think it's easy for you guys to see up here what I'm looking at. And if my pen would stay still, I could shade that one out. Okay, so I'm going to try to prove these two triangles congruent. And what I'm going to ask then now is for your assistance, if you will look. If that green triangle wants to be equal to that green triangle, right now I have an angle and a side and a side. I need one more piece, so I could use one of my theorems. Remember my choices, SSS, SAS, ASA, AAS, or HL. Could I even use HL on these? Why not? They're not right triangles, okay? You don't know about a right angle. So it's got to be one of those, and so far I've got an angle and a side, so I'm thinking I should use one of these, right? Well, what can we do on the diagram, because we're out of the givens. We've got them already listed. Okay, I was trying to give some time, so more of you would think instead of sit there waiting. I've heard it 3 times now already, so I think some of you actually heard what Evan and Carolyn and I think, well, somebody else said it too. We've got some what's vertical angles. You got to go to the diagram and see if there's a shared side or vertical angles, or if they have given you some parallel lines and stuff like that. Here, I see vertical angles, so I'm going to put a double arc mark on them, and I'm going to put that next in my proof. I'm going to call it angle PTS, congruent to angle QTR. All right, why? Because vertical angles are congruent. You can just write vertical angles congruent. Well, what can I do now? Look at the picture. Do we have enough stuff marked to use one of these things? Okay, so we do, because we've got an angle and a side. So it's either going to be angle, side, angle, or angle, angle, side. Now I got to eliminate and figure out which one. Is it the side smushed between the angles or not between? Not. Okay, it would have to be here and here. So that means it's going to be AS, angle, angle, side. All right, now I got to state the triangle congruence. Triangle PTS is congruent to triangle QTR. Looks a lot like my previous statement, but that was about angles that were vertical. This is about triangles. And that's my angle, angle, side. So PT is congruent to QT now. Why are these other parts congruent to each other? Because we proved the triangles are congruent, and that's by BP, C, T, C. We're going to be practicing some more proofs tomorrow. We got a little more to go here. So here's this recipe for doing proof. First, you want to carefully mark all the given information, all right, onto the diagram if it's not already been marked. Then you want to try to figure out what triangles need to be proven congruent by looking at what you're trying to prove, okay? Look for shared sides or angles. That would be by reflexive property that they'd be congruent, and or vertical angles that would automatically be congruent. Then you use the given information, stuff like definition of midpoint or perpendicular or angles are congruent by parallel lines, etc. Anything else that's been given to you that you can use to find some parts congruent. Then finally, when you're able to use one of these theorems, and it has to be right angles if you're using HL, then after that you can use CPCTC to prove additional parts congruent. Okay, so let's try another proof. One more for your ISN. PQ is parallel to ST, so I'm going to go highlight that. These are parallel lines. And then that would mean that the rest of this stuff are transversals. I'm just going to put that transversal highlighted just for the heck of it. I could go the other way, but I think I'm just not going to do that yet. I got PR congruent to TR given, and it's already marked on the diagram. And then I fill in that this stuff was given to me. All right. Well, I don't see anything else given, nothing else to write. So we got to go to the picture and say, okay, what can I use? What can I see? And I'm thinking the first thing you guys would go to on the picture is what? These guys, right? I hope. Yes? Okay. So I'm going to say angle PRQ is congruent to angle PRS because vertical angles are congruent. Now, if you wrote vertical angles theorem, that's what it says. Now what? I don't have any more vertical angles. I don't have shared sides, but I do have parallel lines. What can the parallel lines help me do? So when we, okay, you're probably, some of you are ready to answer me. 1 second. So parallel lines found me special angles. Okay? That's what we're looking for. It's going to help me find some more congruent angles. So more people can remember what they might be able to do with this. All right, so now where can I get some more angles that are congruent in the triangles? Where are they? Can you tell me a name for one of them? Okay, so up here, angle QPR is congruent to angle, you said STR. That's a good choice. By parallel implies, what kind of angles are they? Alternate interior. It's between the parallel lines. Alternate, and they jump over the transversal. Alternate interior angles congruent. Okay, that was, well, what we needed. Now look at the picture and what we have marked. Do we have enough to prove triangles congruent? We do, don't we? All right, let's do it. Triangle QPR is congruent to triangle STR by, okay, now I see two angles and a side. Is it angle side or angle side angle? Okay, see how the sides smushed in between them, really close in between? That's ASA. Okay. Now, the rest of the parts are congruent by CP, CT, C. Did anybody see another way to do this proof? Yep. What were you going to say, Kenny? You did this one? Okay, so if you did PQR congruent to TSR, that's a good way to do the problem. But your reason for here is going to be AAS. Okay? You can do it that way. You also could have skipped the verticals and done both this and this, this and this by alternate interior. And then it would still be AAS, though. I was hoping to get an ASA. So it is doable by using that transversal. Sometimes there's more than one way to do the proof. That's why you got to show the markings so we know that you actually did it by some good method. Was that the last one? Was that everything? So our whole ISN's done? Alrighty, finally, let's go to the worksheet, and we're going to go a little quicker. Okay, ready, set. ISN's all complete. We're going to get this done too. All right, the angle formed by the legs is called the vertex angle. Okay, I don't know why I didn't have an angle word there. The other two triangles, oh, it's not triangles, other two angles in an isosceles triangle are called base angles. Know your vocab. It's easy vocab to remember. Isosceles triangles have two congruent sides, which are called the legs. And the third side of the triangle is called the base. Anybody need this? Okay, bingo. Isosceles triangle theorems. One of them says, if two sides of a triangle are congruent, then the angles opposite them are congruent. So in this diagram, angle B would be congruent to angle C. And that short version of this was, if sides, then angles. Then came the converse of the isosceles triangle theorem. It said, if two angles of a triangle are congruent, then the sides opposite them are congruent. So in this picture, if angle B is congruent to angle C, then side AB is congruent to side AC. And that short version for that was, if angles. Oh, terrible picture. If angles, then sides. Okay. Ready. Boom. So the corollary to that was, if the triangle is equilateral, if and only if it is equiangular. And each angle of an equilateral triangle measures 60 degrees. Okay, example 1. Where are the congruent angles? F and G, yes, because they have to be, didn't mean to grab that. It'd have to be across from those sides is where the angles are that are congruent. So it's angle F congruent to angle G. 2, find the measures of the angles. Well, if the sides are all equal, then the angles are all equal. That means they're all going to be 60 degrees each. Example 3. If FH is congruent to FJ, then angle H is congruent to angle J. If triangle FGK is equiangular and FG is 15, then GK would also be 15 because it would have to be equilateral as well. I should not have put degrees on there, just 15. I hear paper turning. To example 4. This was already in our ISN, guys. I'm going to go really fast. BC was congruent to BA, so therefore these base angles were congruent. And this is exactly what we had in our ISN. So we subtracted 4x. We got x minus 10 equals 5, and we added 10 and got 15. We also took this and put it in the ISN, the next one, which would be if you have angles congruent, then you've got sides that are congruent. So 3x minus 13 is equal to 2x. So what happened there? We would have subtracted 3x from both sides. We would have got negative 13 equals negative 1x and divided by negative 1. And we get positive 13. Next, we have some problems to find the value of the variable. Some of the problems have more than one way to get the job done. I see 2 ways on this one. I know since the sides are equal that angle R is congruent to angle Q. That's only part of the problem. Let's see. Well, that means we could put a 2x here if we wanted. Somebody have a suggestion on what we might do and to solve this problem? Okay, hold on. I think Kenny raised his hand. I mean, not Kenny. It was Murphy raised his hand. What would you like? Okay, so you added 2x and 2x. Somebody have another strategy. There's a whole nother way to do it, but it's really related to what we're about to do. Anybody think about figuring out angle R and angle Q first? Really? Nobody thought about that? Couldn't you just take 40 away from 180? Divide it by 2 and you'd know how big these angles are? Okay, so that's another strategy. 40 minus 180 minus 40 is 140. If you divide that by 2, both of those angles have to be 70. And you need to know that they need to be 70. So then you could just say 2x equals 70, and you'd get divide by 2 and get 35. But that's what this does for you as well. Subtract 40, divide by 4. 140 divided by 4 is 35. So I don't care which way you go about it, right? Figure out the angle, the x value. All right, this one has two congruent sides, which means the sides are two congruent angles. The sides across from those angles would be congruent. So 3x minus 6 equals 2x plus 6 is your setup. Okay, now you know the algebra. Don't be thinking that those 6's are going to cancel each other out, because they're not. We got x minus 6 equals 6, and then you would add 6 to both sides, not subtract. So x would be 12. I'm just going to do a little bit more here. Okay, no. I just did one very similar to number 3. Please, may I have a strategy? All right, Bryce? Okay. Okay. Divide that by 2. Okay, and how big are each of them? All right, so that means this is 45 and 3x equals 45 also. So there's an equation. Bingo. I like that method. So we're good. We're ready to get our answer dividing by 3, and we've got x is 15. Boom. Now I can't use that strategy on number 4. So how about a strategy for 4, please? I know angle A and C equal each other because of your isosceles. Okay, I heard you say 14x, which would be 6x plus 6x plus 2x. Okay, that's the good part. Plus 12, okay, is 180. You got to add them all up for number 4. And then you can solve that. I want to make sure you have good examples. So that's 168, 8. And then dividing by 14, you should get 12. Right. Strategies for 5. Matter of fact, I think we've done enough examples. Somebody want to write on here? Try it. Tell me what to do or show us what to do. Oh, my light's out. I wonder why. I was going to move around with this plate and let you write on it, but unfortunately I'm in caution. Darn it. Okay, someone at least tell me what your thoughts are on how to do this. All right, Bryce wants to go again. Come on, go ahead. Same thing as the other one. All right, so how big was your angle? 5x equals how much? 45. Okay, and that's because if you do 180 minus 90, you got 90 left for the two congruent angles, and they would be 45 apiece. Okay, good to remember that because we're going to be doing special right triangles, 45, 45, 90s in the next semester. Okay, and this one, these would both be x, so you should have gotten 9, right? And these add up to 5x, which equals 45 divided by 5 is 9. Okay. Yep. Times tables. What is 180 divided by 5? Well, you guys probably already got it. 36? Okay. All right. You're getting close to where it says homework. Let's quick do this guy together. ABC is equilateral. That's that whole triangle. If it's equilateral, how big are all the angles? All right, that's what it says right here. So the measure of angle A equals the measure of angle B, which equals the measure of angle C, which are all 60 degrees. Each angle of a angular or lateral. Triangle is 60 degrees. This stuff was given. All right, so what that means is this is 60, this is 60. We can put it on our picture, and that's 60. All right, after that, angle 1 is congruent to angle B. Angle 2 is congruent to angle C. Now, there's a different reason for that. You see these parallel lines? What kind of angles are here and here? Yep. So if parallel lines corresponding angles are congruent. All right. So that was by corresponding angles. So these would be congruent to them too. That's what they gave both of them. They said angle 1 congruent to angle B, angle 2 congruent to angle C. And then they traded 60 in for B and C and made a substitution. Now, if 1 and 2 are 60 and also angles up here is 60, then that means APQ is an equilateral triangle. Because if a triangle is equiangular, then it is equilateral. All right. And now this is where your homework begins. I'd like you to make sure you practice some of these problems, or all of which you can. Be prepared with some questions tomorrow. I'm going to answer some questions on this, plus we're going to do some more proofs so we can get ready for a proofs quiz. I don't know if I'm going to have that be Wednesday or Thursday of this week. Timer, time out.